In this video, we're going to find the total surface area of two composite figures. So the first one, despite my poor drawing, is a hemisphere. So what that means is it's a half circle. So if you've ever seen a snow globe, imagine that this is a snow globe. So half of a sphere. Now this is 3D, it's not 2D, but imagine this is a snow globe, okay? We are given our radius here, which is 13 millimeters. So to calculate the total surface area of the hemisphere, we need to find the area of the curved part of the globe, and then we need to find the area of the circle that makes up the bottom of the globe. So we find the area of the curved part and then add it to the area of the circle down below, and that will give us our total surface area. So TSA equals the hemisphere area plus the circle area. Okay, now using your knowledge of what the formula is for the total surface area of an entire sphere is, you should know that it's 4 pi r squared. Okay, this is the area for a whole entire sphere. So a whole entire sphere. Because we only have half of one, we divide it by 2. And that's how we would find the area of just the hemisphere. Okay, just this part here. Now, this area will just give us the curved part, because if you think about it, if you think of a tennis ball, if you cut that in half, there's no bottom. This area will just give you an area for this curved part that you have left over of half of a tennis ball. There's nothing to say that you're finding the area of that hollow part that's left underneath. So in order for us to find the area of that circular hollow part underneath, we need to find out what the area of a circle is. So the area of a circle is pi r squared. And that's the area of this second part. So the area of a circle is this blue part here. And the pink part is the tennis ball, snow globe, whatever you want to think of it as, curved part. Okay? So the pink is the area of this curved part, and the blue is the area of the bottom circle. Because total surface area, remember, is the area of each face of a shape. Okay, so now that we've got the area for both parts of this shape, we can go ahead and substitute the values into the formula. Now, I'm going to rewrite this and simplify this 4 divided by 2. You should know that 4 divided by 2 is obviously 2. So I can actually simplify this into 2 pi r squared plus pi r squared. Okay, now we can go ahead and substitute our values in the formula. You can do that. You can definitely put all your values into this formula. I'll show you how we would get an answer. So this is one route we can take. So 2, remember no gaps equals imaginary time sign. So 2 times pi times the radius squared, and our radius is 13. Now I'm going to put brackets around both parts so we don't get confused. Plus pi times the radius squared, which is 13 squared. Now I can put that into my calculator exactly how I see it. So bracket 2 times actual pi button times 13 squared, closed bracket, plus pi times 13 squared. And I get an answer of 1592 point, and 2 decimal places is 0.79. Millimeters squared. That's one way you can do it. You're still going to get the same answer, but I will show you how we actually could have done this and saved ourselves a lot of time. Now, if you look at what we have here, we have 2 pi r squared plus pi r squared. Because this is just pi r squared, there's an imaginary 1 out the front here because there's only one of these. So if we simplify this, we can actually get 2 plus 1 equals 3. So 3 pi r squared. Because we have 2 of the pi r squareds here, and we have 1 of them over here. So add them all together. How many pi r squareds do we have? 1, 2, 3. 3 pi r squared. And now instead of having to repeat values and do all of this working out, we can just use this formula. So let's substitute our value into here. No gaps equals imaginary time sign. So 3 times pi times 13 squared. Let's see if we get the same answer. 3 times actual pi times 13 squared equals, look at that, we get the exact same answer. Okay, I'll just write it down here as well. So we actually end up getting the exact same answer. Now, like I said before, you can actually you do the formula exactly how you see it here. It'll take a little bit longer, but if you're going to have confidence in yourself knowing that you will get the right answer, then do this. If you don't feel so confident with collecting like terms and simplifying by adding not just numbers but pronumerals as well, then don't do this, because then there's a chance of you getting confused. If you're happy with this side, then do that side, okay? But that's how we find the total surface area of a hemisphere. Now, the second example that I'm going to show you is calculating the total surface area of a cylinder that has a cone stuck on top of it. Now, remember, when we calculate total surface area, we're finding the area of the outside faces of the shape. So anything that's inside this 3D shape, anything on the inside of it, it doesn't count, okay? Because total surface area means the outside. So to find the TSA of this, we'd need to find the area of this circle down the bottom. We'd need to find the area of this entire curved part of the cylinder, and we would need to find the area of the cone on top. I am not including this circle in here. This is a hollow shape. The inside doesn't exist. The inside is just space. So because the inside is just space, technically this circle doesn't even exist in there. It is all space. So I'll write down what I need to find the areas of. So the total surface area equals the circle down the bottom plus the curved cylinder plus the cone. Just the curved part. Right, so we need to find these three area values and then we can add them all together to get the overall total surface area. Now, the TSA of a cone is, now I'll work backwards here. The TSA of a cone is pi r squared plus pi rs. So I'll write that down. And remember that when we have our cone, this pi r squared belongs to the circle and this pi r squared belongs to the outside part of the cone, so the curved part. Because to find the total surface area of this only needs the curved part of the cone, we do not use this whole entire formula. This pi r squared is just the area of this circle here. This does not exist in there. It's hollow, okay? So I'm going to cancel that part out and be left with just pi rs, okay? I'll also get rid of that plus sign. So the area of the curved part of the cone is pi rs. Now let's go to a cylinder. So the TSA of a cylinder, and I'll just do that in pink. The TSA of a cylinder is 2 pi r squared plus 2 pi rh. Now you need to be careful here as well because we do not want this part here. Just like we didn't want it in the cone, we don't want it for the cylinder. It is hollow. There is nothing in here. We only want this circle here because if we look at just this cylinder, the bottom circle is the only thing that we can see on the outside of it. All right. Now from here, this part of the formula calls for in a cylinder, if I just write it again, draw it again as a net. This part here, the 2 pi r squared, means these two circles here because the area of a circle is pi r squared and we have two of them. So that's where this part of the formula comes from. This second part is this rolled out circular bit. So this part that curves around the whole cylinder is the 2 pi rh. To make things easy for us, we could technically think about this bottom circle as part of the cylinder, but I actually want to think of it in terms of the circle that's down the bottom. So for this cylinder, I only want the curved part. I technically don't want either circle. I only want the curved part because I'll think about this circle down here over here. So these two circles need to disappear. This needs to disappear as well. And we're left with 2 pi rh, which is the area for just this curved part. And then lucky last, we've got the orange circle down the bottom. So I'll do it in orange. Obviously, you know that the area of a circle is pi r squared. Now I just need to substitute my values in for each of these colors and I'll find the total surface area. So here we have our radius, so half the circle. 13 is our slant height, which is our S, and 25 is our height, so the height of the cylinder. And let's go substitute in. TSA equals, now I'm going to put brackets around each three of these things so I don't get confused. Pi times the radius squared, so the radius is 8, plus 2 pi RH, so 2 times pi times the radius, which is 8, times the height, which is 25. Bracket, plus, lucky last, the cone. So the cone is pi RS. So pi times radius, which is 8, times the slant, which is 13. Closed bracket. Now, this next part is up to you. Put it in your calculator exactly how you see it, like this, or do each part separately. But be careful, if you don't trust yourself with putting the whole entire thing in as you see it, you need to be wary of the fact that you've got pi's here, and I don't want you to be putting in 3.14 as the value for pi. I want you to use the actual pi button. So for each three of these answers, you are going to get very long decimal answers, which will waste time if you write down every single number after the decimal, and you're losing time if you were doing a cat, for example. So I'd rather you put it in as one line, but if you want to do it the other way, you can, but I advise this way. So let's put it in exactly how we see it, like I say all the time. Bracket, pi times 8 squared plus 2 times pi times 8 times 25, bracket, plus pi times 8 times 13, bracket. We'll press equals, and we get an overall answer of 1784 and we're going to 2 decimal places unless otherwise told so, 42 millimeters squared. So the trickiest part about total surface areas of any composite shape, now I mean even something like a cylinder with a hemisphere on top of it, you need to be able to visualize this in your head as a 3D shape and only take parts of each shape that are shown from the outside. We are not interested in any insides because we are imagining that this shape is hollow and there is nothing on the inside. So if you are able to look at this shape and identify which shapes make it up and then take their formulas and cross out which parts we're not interested in, then you will be fine, because this is the hardest part. The rest of it should come naturally.